Let's practice working with function notation together. Now for this particular video, there's only two main questions, but they're going to have a bunch of parts to them as well. Now for each one of these examples, we're going to be taking a look at a function. We're going to figure out some coordinates that are a part of the function. We're going to fill in a table as well as graph that particular function. Also, there are going to be maybe a couple follow-up questions that we're going to answer along the way as well. All right, so for number one, it says to go ahead and use f of x. So if we take a look at f of x, that's going to be this function right over here. So let's make sure we don't use g of x or h of x for this particular problem. So let's get right into it. The first one says find f of -2. So if you just plug in -2 in for x, this is going to be 2 multiplied by -2 minus 3. This is going to be the same thing as -4 minus 3, which is equal to -7. Okay. The next one is f of -1, so keep using this f function here. So this is going to be 2 multiplied by -1 minus 3. So 2 times -1 is going to be -2 minus 3. That's going to be equal to -5. Then for f of 0, it's going to be 2 multiplied by 0 minus 3. So 2 times 0 is going to be 0. So we have 0 minus 3. That's going to be equal to -3. Next, we have f of 1. So that's going to be 2 multiplied by 1 minus 3. 2 times 1 is going to be 2, so we have 2 minus 3, and that's going to be equal to -1. And then finally here we have f of 2, so we have 2 multiplied by 2 minus 3. 2 times 2 is going to be 4, so 4 minus 3, that's equal to 1. Notice we're dealing with a linear function here, and each of these x values essentially went up by 1. And notice that each of these y values, or f of x values, went actually up by 2 here. We'll talk more about that in another video, but from this we can go ahead and try part B, which is writing 5 ordered pairs. Now keep in mind that when you look at an ordered pair here, this is an x value and this is essentially the y value, right? So for each of these ordered pairs, we just basically found them in part A. So we can say that -2, -7 is our first ordered pair. Then we had f of -1 was equal to -5. That's a second ordered pair. Third one was f of 0 was equal to -3. That's another ordered pair. Then we have f of 1 is equal to -1. And then finally we have f of 2 is equal to +1. So there are 5 ordered pairs that are we found out from part A there. Okay. Next, we can go ahead and fill in a table here. And so for the table, we're just going to go ahead and plug in each of our x values. So for our x values here, we have -2, we have -1, we have 0, we have 1 and 2. Those are all the x values that we plugged into that f of x function. And each of the associated f of x values were -7, -5, -3, -1, and +1. So just using all the same information from parts A and B. Okay, let's go along to part D. Here we're going to go ahead and graph this function of f of x on this coordinate plane here. We're going to stay with this domain restriction though, it looks like. This is going to be a domain restriction just because we have x values that are being restricted. So let's see here. We can plot our points here first. So let's see, our first point we said was going to be -2, -7. So that's going to be down in quadrant 3. That's over here. Then we're going to have, let's see, when x is -1, y was -5. That's right here in quadrant 3 as well. 0, -3, that is on the y-axis. Then 1, -1, that's in quadrant 4. And then we had 2, +1, that's going to be in quadrant 1 here. So here are 5 points that we came up with just a moment ago, and they're plotted on the graph. Now what you can do is you can connect all these points to create this entire function here. And so this really does go in both directions infinitely. That's what's going to happen by default with functions. So you can go ahead and kind of put an arrow here, right? Because lines will go on forever. You can keep plugging in different x's to get different f of x values or y values. However, we are being told to restrict this function by a domain restriction saying x can't be smaller than -3. So if you take a look here, here's where x is -3. And notice that the function shouldn't go past here. So I'm actually going to go ahead and just put a dot here. And we're going to stop the function at that value. So we're not going to go past it. So we're going to stop right at x equals -3. And we're going to go up until when x is equal up to 5, right? So actually here you can see here's x is 5. So we can actually go a little further here. So I'm going to go ahead and get rid of this arrow on this other side. And let's keep this going until we get up to x is 5. So right over here, that looks pretty good. Okay, so what we just found out here is if you did f of 5, you would actually get 7, and that hopefully makes sense here because that's a point on our graph here. So typically, again, these functions would go on forever in both directions. However, we're restricting this because we have a domain restriction here saying x has to be between these two values. So in this example, we have a domain restriction, and we can say that because the x values or the inputs of the function are restricted. All right, now for a couple follow-up questions. So here in part E here, we see that f of x is equal to negative 15. So again, that's really just a y value. So they're saying when y is negative 15, what's x going to be? So let's see, what is that f of x function? It's f of x is 2x minus 3. So I'm going to go ahead and just write down the function. F of x is equal to 2x minus 3. And we're being told that f of x is negative 15, so just replace or substitute f of x with negative 15. Negative 15 is equal to 2x minus 3. Then let's go ahead and add 3 to both sides here. If you add 3 to both sides of this equation, you can see here, we're going to end up with negative 12 is equal to 2x. And let's see here, let's go ahead and just move over here to get some more space. So if we have negative 12 is equal to 2x, we can go ahead and divide both sides by 2. And if we do that, we can see here that x would be equal to negative 6. So if we were looking on that graph, we would see the point there that f of negative 6 would be equal to negative 15. It wouldn't fit on the graph we have on this paper, but if you could add on some more boxes onto the coordinate plane or zoom out a little bit, you would see the point there of negative 6 comma negative 15 would be on there. All right, one more follow-up question. This is just another output. We're going to find the input that's associated with it. So let's see. We know our function is f of x is equal to 2x minus 3. So let's just start by writing the original function here. F of x, or the y value here, is going to be negative 3 2/3. So I guess just practicing with some fractions here. That's equal to 2x minus 3. Let's go ahead and just solve this two-step equation just like we did in the last one. We just have to remember how to work with fractions a little bit. So let's add 3 to both sides here. On the left side, we're going to have negative 2/3. If we go ahead and add those fractions, that's equal to 2x. And then let's see here. We can just go ahead and take that equation. Let's go ahead and divide both sides by 2. So if we divide both sides by 2, or you can multiply both sides by 1/2 if you want to, right? So that would be, I'm going to write this on the side here. That's going to be negative 2/3 divided by 2 is the same thing as times 1 over 2. If you cross cancel, that would be negative 1 over 3, right? So x should be negative 1/3. And so that means if we were to look at our function, f of negative 1/3, or if negative 1/3 went into the function as our x value or input, negative 3 2/3 would come out as our output or our y value for that particular x value. So the ordered pair that we would have on the coordinate plane would be negative 1/3 comma negative 3 2/3. That would be our point. All right, now that we've got one practice problem done, let's try one more, but this time in number 2, we're going to be dealing with a different function. So here we're going to be dealing with the g of x function. So let's go back to the beginning and see what function that is. Okay, so here it is here. We have g of x is equal to this negative 2/3 x plus 2. And so I don't have to keep going back and forth here. Let's go ahead and just copy this down. G of x is equal to negative 2/3 x plus 2. Let's go ahead and just copy this and move it over. All right, so let's see here. This is the function we're going to be dealing with. And let's use this one over and over. So we have g of negative 2. So that means x is going to be negative 2 here. So we're going to have negative 2/3 multiplied by this negative 2. And then we're going to add 2 on afterwards. So negative 2/3 times negative 2 over 1 is going to be positive 4 over 3. Then if we go ahead and add 2 onto that, 4 over 3 is 1 1/3. 1 1/3 plus 2 is going to be 3 1/3. Okay, let's see here. For g of negative 1, let's go ahead and take our g function. We have negative 2/3 multiplied by. This time it's going to be negative 1. Then we're going to add on 2 afterwards, right? Now, negative 2/3 times negative 1 is going to be positive 2/3. Positive 2/3 plus 2 is just going to be positive 2 and 2/3. All right, what about g of 0? Here we're going to have the coefficient of negative 2/3. This time we're going to multiply this by 0, then add on 2. So negative 2/3 times 0 is going to be 0. So we have 0 plus 2, and that's going to be equal to 2. Next we have g of 1. So we have negative 2/3 multiplied by 1. And that's going to go ahead and add 2 afterwards. So negative 2/3 times 1 is going to be negative 2/3. And if you add negative 2/3 and 2 together, it's really the same thing as 2 wholes minus 2/3, which is going to be positive 1 and 1/3. Finally, for g of 2, we're going to have negative 2/3 multiplied by positive 2 here, and then add on 2 afterwards. So negative 2/3 times 2 is going to be negative 4/3, or negative 1 1/3. And if you go ahead and add on 2 after that, that's just going to be 2 minus 1 1/3, which is going to be equal to 2/3. Now notice how as each of these x values seem to go up by 1 here, each of these g of x values or y values are going down by 2/3 each time. So that pattern checks out too. Now, what are the ordered pairs that we can gather from this information? Well, g of negative 2, the negative 2 went in, and then 3 and 1/3 came out. So that's going to be the y value, right? And then we had a g of negative 1, so negative 1 went in, and then 2 and 2/3 came out as the output there. Then for g of 0, the 0 is our input, and then this positive 2 is going to be our output. Then for the next one, g of 1, 1 is our input. Then 1 and 1/3 is our output. And then finally, when 2 is our input, g of 2 got us this value of 2/3. So our output is going to be 2/3 here. Okay, so those are the 5 ordered pairs. Let's go ahead and now put this in our table. So each of our x values are just negative 2, negative 1, 0, 1, and 2. And all their y values or their g of x values here are 3 and 1/3, 2 and 2/3, 2, 1 and 1/3, and just 2/3 here. Those are all the y values that go with each x, or those are the g of x values that go with each particular input of x. All right, let's check out part D. We're going to go ahead and graph g of x here. So if we go ahead and graph our g of x function, we actually have a bunch of dots that we can place, or ordered pairs here. So negative 2 comma 3 and 1/3. 3 and 1/3, you're gonna have to estimate a little bit. It's gonna be 1/3 of a box up here, okay? And a negative 1 comma 2 and 2/3, that's gonna be over here, which is, I guess, 2/3 of the box up here. And then 0 comma 2, it's gonna be on the y-axis. Then 1 comma 1 and 1/3, it's gonna be 1/3 of a box up here. And 2 comma 2/3, that's gonna be over to 2, but then 2/3 of a box here. So if you're gonna go ahead and draw a line through this, we have a linear relationship, so we get a straight line. It's going to look something like this. And if we didn't have any restrictions, we'd have these arrows on both ends, and it would go infinite in both directions. However, we do have this restriction here, right? Now, what's being restricted? Well, it looks like the restriction is of the y's. So if we're restricting the y's here, then this must be a range restriction, okay? We're being told that y can't go below -6. It's allowed to equal it, right? It's -6 is less than or equal to y, and it's allowed to equal 8, but it can't go past 8. So where's the y value of -6? This is a y value of -6, so it can't go below here, okay? And then where is the y value of 8? Well, that's over here. So basically what this range restriction is telling us is we can't go above and below these two blue lines here. Okay, so let's go ahead and get rid of these arrows because it doesn't go on forever in both directions. I'm going to go ahead and shorten this a little bit here. And if you want to put a dot here, that's perfectly fine. Okay, that kind of shows us that we stop at the value of 8. And in terms of the bottom portion of this, it doesn't look like our graph goes down low enough to get to -6. But what we can do, just for the sake of keeping it as clear as possible, maybe, I think I did get to -6, even though it's off the graph here. So I think I did an okay job at getting to -6 there. So this would be our function if we have this range restriction here. So let's go ahead and say that this is a range restriction. So we know we have a range restriction here because the y values or the output values are being restricted here. All right, let's go ahead and solve some additional questions here about this particular function. We're being told that g of x is equal to -7 1/3. So let's see here. We know our function is g of x is equal to -2/3 x plus 2. That was our original g of x function, right? In this case, we're being told what g of x is, so that output is -7 1/3, and we're being asked to find what's the input that gets you that particular output. So let's go ahead and plug in -7 1/3 in on the left side of the equation where the g of x is, or where the y would be. And let's go ahead and solve this two-step equation. So first, let's go ahead and subtract 2 on both sides of the equation. Once you go ahead and do that, on the left side, we're going to have -9 1/3. And that's going to be equal to -2/3 x. Okay, next let's go ahead and use the multiplicative inverse property and multiply both sides by -3/2. And let's multiply by -3/2. If we do that, we're going to see here that x is going to be alone on the right side, but I'm going to move it to the left side here. And we just have to go ahead and multiply these two fractions together. Remember, on the right side here, these are reciprocal, so when you multiply those, you get 1. So using the commutative property, you can kind of just rearrange that multiplication. So on the left side, we have a little bit of work to do. This is me -3/2 multiplied by -9 1/3 as an improper fraction is going to be -28/3. I think we can cross cancel here a bit. So the 3's will cross cancel and the 2 and 28 will cross cancel to make 14. I think we're going to get +14 here. So x is going to be equal to +14. So what do we know from this? We know that the g of 14, if 14 was the input, then we know that this -7 1/3 would be the output. And from that, we know that on this particular function's graph, 14, -7 1/3 would be an ordered pair or a point that is on this graph of this function. All right, one more time for f. Let's go ahead and try another extension here. So g of x is equal to, let's just write the original function so everything's very clear and organized. And then we're being told that g of x is -8 2/5. So -8 2/5 is going to go on the left side here. That's going to be equal to -2/3 x plus 2. So again, we're given the output here of -8 2/5, and we're being asked to find what particular input would lead to that output. Okay, so we can find that out by solving a two-step equation, right? And if we go ahead and subtract 2 on both sides here, we're going to get -10 2/5 on the left side of the equation. On the right side, we're going to have -2/3 multiplied by x. Now, similar to the last one, we can just go ahead and use the multiplicative inverse. Let's multiply both sides by this -3/2 and multiply by -3/2. On the right side here, these reciprocals, of course, will multiply to get 1. That's using the multiplicative inverse property. So we're going to have 1x, or just x equals. And what about this multiplication problem? It's a negative times a negative, so we know it's positive, but I'm going to have to do some work on the side here. So for some calculations, -3/2 multiplied by negative, and then -10 2/5 as an improper fraction is going to be -52/5. Okay, and so the 2 and the 52 can cross cancel to make 1 and 26. So I think this is going to be, let's see, it's 1 times 5 on bottom, and then 3 times 26 on top. I think that's going to be 78 here, right? So I think that's going to be what our numerator is. Now, 5 goes into 78 15 times. 15 times 5 is 75, so it's 3 left over. So it's going to be 15 3/5 here. So 15 3/5 would be our x value. So what did we just find out? We found out that g of 15, I'm going to write 15.6, that's 15 3/5, is equal to -8 2/5, or I'm going to say here -8.4, just to practice using some decimals here, right? If you're looking on the graph here, you would see that 15.6, comma -8.4 would be a point that is on this function. All right, so there you have two different examples. Each of them both had lots of different parts to hopefully help you build a stronger understanding of how functions work and how you can take the functions, use the inputs and outputs to help you come up with ordered pairs, fill in a table, see what it looks like on a graph, and also graph using a domain or range restriction, and then just practice finding some additional inputs and outputs in those different cases. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.